Load my NFL FastR, and as I learned last time, I also have to load my Tidyverse. Alright, I do this option statement so I can view tables and all of their columns. I know that's not the default setting. I like to view my data that way. It used to actually be the default setting when the Tidyverse was in its infancy, and I kind of got used to it. You don't have to do it. Otherwise, the Tidyverse will only show the first several columns if the data is too wide, and then it will list out the column names for the rest. I like to show all of them. All right, so I'm going to load in the current NFL play-by-play data set from this season, which is 2023 when I'm recording this. All right, so now in the last sub-module, we showed the unique rows of data between each possessing and defensive team. But now I want to count how many rows of data there are between each of those teams. So this will look similar to before, but now I have the number of plays using this end parentheses function inside my summarize, right? And I named it plays is equal to end parentheses. So that's how many plays are between these offensive team and this defensive team. So Arizona on offense has faced Atlanta on defense 82 plays, right? And I could look at how many, what's the biggest number of plays between two teams in the season so far. Okay, so if I want to then calculate the total number of plays and ignore possessing team and defensive team, I could type total plays equals the sum of the plays column, and that should collapse it down to just a single row. But you'll notice it doesn't here. And the reason why it doesn't is I didn't ungroup the data first. So I had grouped by possessing team and defensive team in the previous code or in here. All right, and then when I summarize by plays, it ungroups the last column that it grouped by, which would be defense team. So you'll see here when I do that, it says here, I still have a group, and that's possession team. There's 33 unique values of that. So then I summarize total plays, it'll group by the possessing team, which is here, and now I have a table of 33 rows, and it'll give the total number of plays for each team. Okay, so now if I want to have the total number of plays in the NFL this season, I could ungroup after that first one, and then I summarize total plays and sum up all the plays, and then I would get 31,492 plays on the season so far. All right, so we could use a count function as well. Like I said, if we just do play-by-play, count how many possessing defensive team, it'll default calling that number R. But if we recall, this is the same number, 82, 92, 73, as we had before. 82, 92, 73. Okay, but I want to rename the plays column to be plays instead of N, and we'll get the same exact looking table as we had before. Okay, so now I want to summarize data by the down. First, second, third, fourth down. So first I need to get rid of rows where there is no down or it's missing. And also I want to get rid of rows where there's no EPA. I don't know why there might not be EPA, and that's not a subject to this course, but there are some rows where that's missing. And I want to then do some summary statistics like average yards to go, average yard line, average EPA. EPA is short for expected points added. If you're not familiar with that term in football, it's a sports analytics concept where we talk about the expected number of points given that situation in the game that an offensive team is expected to score. It can actually be negative too if you expect the defensive team to score before you. Say if you're backed up against your own end zone. All right, so I'm going to get rid of where it's missing down and it's missing EPA. I'm going to group by the down, and then I'm going to calculate these summary statistics. So mean average yards to go, average yard line, average EPA, standard deviation, EPA, the max yards to go in the data set, the 97.5th percentile and the 2.5th percentile, and the mean squared error between the expected points added and the expected points. So the expected points is the average at the beginning of the play. Expected points added is you take the expected points on this play and you look at the expected points on the next play and the difference between the two. If you have a positive EPA, then your team should be getting closer to scoring or more likely to score more points. If it's negative, you're less likely to score as many points as a result of the play. So we can use that as sort of a determination if the play is successful. But I'm doing this to show you and to do a summary of this model that the NFL FastStar data set uses to look at the mean squared error in the expected points added versus expected points. Okay, so here I have the down for grouped by, okay, and you'll see that, which makes sense, on average at first down it's almost 10 yards to go. If you know football, that's almost always the situation, unless there's a penalty. And then you'll see with each subsequent down, the yards to go, it goes down, but then in fourth down it actually goes back up. And then the average yard line on each subsequent down, it hovers around 50, but you would expect it goes a little bit closer to the end zone with each down. The average EPA, so on first down, teams on average have negative EPA, means on average they're unsuccessful. Same with second and third. And then on fourth down, it's a little bit positive. All right, and then we can look at the max yards to go in this data set. So first and 34, that did not look like it was probably very successful. So here we got rid of the missing down and distances. Now if we don't do that, and so I'll comment that part out of the code, you'll see that I'm not going to get the same results. All right, and I get some of these errors essentially because it says, well, down, there's a missing value in down. So it can't even group by, you can't group by a missing value, okay? Now we can make sure that we filter out that down is not missing. And if we want to be careful to make sure that we don't have any places with missing EPA, we can do these na.remove statements, and then these summary functions will remove any missing data in those columns when it encounters them before it calculates the data set, like so. Just like in the code example I showed you in the slides, if I try to filter on pass and penalty with a comma, it will return nothing. And in this situation, I will have it be an OR statement with this vertical bar, and then it will show any pass or penalty play in the data set. And so here we have over 13,000 rows in our data. Like I showed you before, we can group by our play-by-play by quarter. So if I do that and you scroll to the top here, you can see this is a lot of columns of data right in this NFL play-by-play. So I can't even scroll all the way to the top, which is frustrating. That's why the options with equals INF might not be always appropriate for you if you have too large of data. So I can see why the authors of the Tidyverse made it a default not to show all the columns if there's too many. But I can group by this, by the quarter, and then I can filter yards net is greater than the mean. I'm going to remove missing data from where the yards net is missing. Okay, and then, okay, and so this, all this does is filter in my data set. So I'm only showing rows where the yards gained on the quarter was higher than the average. The yards gained on that play was higher than the average yards gained for the quarter.